right, last time we were looking at divisibility. We had looked specifically at quite a few different rules for specific numbers. We'd also looked at some interesting things at the beginning where we decided whether things were or were not divisible by sort of the factoring maybe of them or something like that. And we have just a little bit more to take a look at in that regard in this section. So we're going to jump back in where we left off. And we left off here. So we are going to classify some statements as true or false. And I do realize it's been 4 days since we've talked about it, so we may have to go back and brush up on a few things as we go. The first one asks us if a number, to classify if it's true or false, if a number is divisible by 6, then it must be divisible by 2 and 3. Is that true or false? That is true. And the reason it's true, I know it doesn't ask us for this, but let me just sort of verbalize it. The reason it's true is because 6 already is divisible by 2, so any multiple of 6 is divisible by 2. And 6 is divisible by 3, so any multiple is divisible by 3. And we had a property that actually specifically said that at the beginning last time. It was this one. Right? If a number divides something, it divides any factors as well, or any multiples of it as well. Okay? The next part actually flips it around, though. It says, if a number is divisible by 2 and 3, then it's divisible by 6. So what do you think? Well, in general, it's false, but it's actually true for the 2 and the 3. So we left off last time with talking about a very interesting divisibility rule, and it was the divisibility rule of 6. Do you remember that one? I gave you a list of numbers, and we tried to look for what the things had in common, the lists had in common, and Kimberly's the one who actually noticed that in one list, all the numbers had nothing in common in pair form, right? This one on the left had nothing in common. 2 and 3 don't have anything in common. But all the ones on the right did. 2 and 4 do have something in common. 10 and 12 do have something in common. So when I don't have anything in common, and I know the number is divisible by 2 and 3, then it is divisible by 6. And there's a whole series of other numbers that would fit into this statement and be equally as true, right? If it's divisible by 2 and 5, it must be divisible by 10. If it's divisible by 5 and 3, it must be divisible by 15. But it doesn't work for all numbers, right? If it's divisible by 4 and 6, it's not necessarily, or doesn't have to be divisible by 24, all right? So this is actually a true statement, but it's not true for all numbers. It's just true for the 2, the 3, and the 6 specific example we're looking at. How about C? If a number is divisible by 8, is it divisible by 2 and 4? Yeah. It is. It's that theorem that's back in the earlier part of this section, right? If it divides 8, it's got, if it's divisible by 8, it has to be divisible by any component of 8. So this one is actually also true. How about for D, though? If a number is divisible by 2 and 4, then it is divisible by 8. It's actually false. Now, in general, when I give you a question like this, I usually ask you that if it's false, you show me an example showing it, right? It's called a counterexample. So just for the sake of sort of thinking through that here, can somebody create a counterexample? 12. So 12 works as a counterexample because 2 divides 12, yes. 4 divides 12, yes. But 8 does not divide 12. And again, the reason this fails is because 2 and 4 have a factor in common, whereas 2 and 3 didn't. Okay? We don't have divisibility rules just for every number. In fact, you might have noticed when we were looking at our divisibility rules last time, so if you think about this slide right here, oops, I missed it. Here. Glaringly missing is 7. I don't have a divisibility rule for 7, right? And I don't have a divisibility rule for, just every number, but there are some other things that we can do when it's a number we don't have a divisibility rule for. So let's take a look at some examples of just some random values, kind of, and some random kind of ideas. They don't fit into sort of any specific category. They're more of a problem-solving approach to think through them, all right? So to put that, information into action because it's not super specific. Okay, so taking a look, we have the number 34,000 51, and we want to know if it's divisible by 17. Now, 17 is probably not a number that you know, like the list of multiples of 17. I mean, like I don't. But we could come up with a few multiples of 17 pretty quickly if we wanted to, by simply multiplying 17 out a few times, right? So if I had 17 times 1, that's 17. What's 17 times 2? 34. And 17 times 3? 51. And we could continue going, but that's actually enough. What I want you to recognize as you take a look at this is that there's a 34 in this problem, and there's a 51 in it as well, right? When we were working in Chapter 3, we talked about some different methods for estimating and for computing mentally whether or not numbers were divisible. And one of the ways we did that would be with dividing these up, right? So does 17 divide into the 34? Yeah. And does it divide into the 51? Yeah. So this is actually divisible because the numbers happen to work, right? 17 divides 34 and 17 divides 51. That's why it works. If the 51 had said a 52, what could you know automatically? It's not going to work. Are you with me? Yeah. All right, so how about thinking along those same lines, 19,031? Is it divisible by 19? No. What's wrong? So the 19 divides by 19 is good, right? That part would have been okay. But you're exactly right, Brooke. 19 does not divide 31. 38, but not 31. So it doesn't work. Now, technically, could you multiply 2 times 3 times 5 times 7 out and answer this question? Yeah, you could, but you'd kind of be wasting your time. Okay? There's no need on this problem to do that. This question wants to know if this number 2 times 3 times 5 times 7 is divisible by 5. And the answer is yes. Why? Yeah, I have the 5 listed as a list in my, if I write it all in factored form, the 5 divides it because it's a listed factor, right? Now, if the 5 had not been here, like let's say this weren't here, and it was just 2 times 3 times 7, will that be divisible by 5? No, because 5 isn't one of the factors. But this is actually really nice. It's in factored form, because, so I can see that it has a factor of 5. 2 times 3 times 5 times 7 is a factored form. Including 5. It includes the number 5. Now D is a little different. It's not in factored form. It has this sort of weird +1 business going on at the end, right? So there's a couple of things to sort of be aware of. We know that 5 is a divisor of this piece, right? Okay. Is it a divisor of 1? Well, no. 1's the only divisor of 1, right? So in order for this to be divisible, it would have to be divisible on each of the components that are separated with the addition. It works on the first piece, but it doesn't work on the second piece. Let me present another thing to think about. If you know from part C that this number is divisible by 5, how will it end? 5 or 0? One of the two. It'll actually end in 0 because there's a 2 in the number as well. But 5 or 0. So since it ends in 5 or 0, what will happen when you add a 1? What will this new number end in? 6 or 1. And if it's ending in 6 or 1, that can't be divisible by 5. So it's a very different line of thinking, but those are both equally good ways of thinking about this particular problem. Okay? So, all right, I think that's the one I had written down here. Yeah. So no, because 5 divides 2 times 3 times 5 times 7. So that number ends. And I know it ends in 0, but I'm going to say 0 or 5 because it really doesn't matter. it ends in 0 or 5, so this number ends in 1 or 6. That's not going to work. All right, think about this next one. We have a number 24, and 24 is a divisor or a factor of this other larger number, m. So if that's true, 24 divides it. What other numbers would divide m? 12 and 2 would. What else? 6 and 4. 8 and 3. And 1 and 24. And I already have 24 listed, so I can just list the number 1 if I'd like. Basically, the answer is what? Well, it's anything that divides 24. If a number is divisible by 24, then all of the factors of 24 also will divide it. And these factors occur in pairs. I kind of liked how you were saying that, Alicia, because we see that, right? And the other one that I didn't write down, of course, was 24 because it was already listed, not because it doesn't work. Yeah, they occur in pairs. Okay, let's think about the next one. We're filling in the blank. Trying to find numbers that will divide by the following. So we've got the number 543,220 something. All right, so there's 10 possible numbers that could go in that last spot. And we would want to know what numbers could go in that last spot and make it divisible by 2. So how could the number end and the value that I've started with my new number at the end, what could those numbers be that it ends with and be divisible by 2? 0, 2, 4, 6, and 8, right? Yeah. What about if I had to make it or wanted to make it divisible by 3? The divisibility rule for 3 has nothing to do with how it ends. What's the divisibility rule for 3?
The sum has to be divisible.
Yeah, the sum of the numbers has to be divisible by 3. So what do I need to do in order to figure out how it ends? I need to add them together, right? I need to figure out what my current sum is. So what is 5 plus 4 plus 3 plus 2 plus 2? 16. Does 16 divide by 3? No. So I can't end in 0 because that would be equivalent to having the 16 I already have, right? So I can't end in 0. What could I end in? 2 would work. If I ended in 2, my sum would be 18. What else could I end in? 5. If I ended in 5, my sum would be 21. What else? 8. And if I ended in 8, my sum would be 24. 9 won't work, and now I'm out of numbers. So there's 3 possible numbers that it could end with based on adding up what I currently know the numbers are. So then, what numbers could I end with so that I have a number divisible by 6? 2 and 8. Why? Yeah. It's the intersection of those two lists, right? It has to be in common to 2 and common to 3. Good job. Nicely done. If we have a number and it's divisible by 5, can it be divisible by 10? Yes. Must it be? No. It can be, because it could end in a 0, right? But 0 is not the only thing it could end in. It could end in a 5, and if it ends in a 5, then it would not be divisible by 10. If a number is divisible by 10, can it be divisible by 5? Yes. Must it be? Yes. All right, the direction of the argument here matters. If I'm divisible by 10, I know the number ends in 0. And if it ends in 0, then it's automatically divisible by 5. All right, the next one's a fun one. A number in which each digit except 0 appears exactly 3 times is divisible by 3. For example, 777,555,222 or 414,143,313. They're divisible by 3. Why would that have to be true? You're thinking along the right lines.
It's like multiplying, like if you do 7 plus 7 plus 7, it's also 7 times 3.
Excellent. I'm going to write it down that way because I like the way you said that. Okay, so 7 plus 7 plus 7. And I can do that with all the numbers, right? This is the same as 3 times 7. Agreed? And if I did that with the next one, what was it? 5s? 5 plus 5 plus 5 is the same as 3 times 5. And then 2 plus 2 plus 2 is the same as 3 times 2. Each of the components I'm adding together is a multiple of 3. So their sum is going to be a multiple of 3 as well. So each number is present 3 times. So we have 3 times that number. And every number, every digit, let me say it that way, every digit is 3 times that digit. Hence, the sum is a multiple of 3. Must this statement be true in order for a number to be divisible by 3? No. Can you give me an example? No. The number 6 is not in a repeating 3 times kind of form, but 6 divides by 3. Right? Yeah, so it doesn't work like that. Any questions?